If no oxygen in space, how is Sun still burning? The Sun is not actually burning in the sense that we typically think of flames and combustion. Instead, the Sun is a giant nuclear fusion reactor where hydrogen atoms are fused together to form helium. This process releases an enormous amount of energy, which is what powers the Sun and allows it to emit light and heat. The fusion reactions in the Sun's core occur at temperatures of about 15 million degrees Celsius and require immense pressure to occur. This pressure is created by the immense gravitational forces within the Sun, which hold the Sun's mass together. So, while the presence of oxygen is not necessary for the Sun to produce energy, it is the fusion of hydrogen that powers the Sun's ongoing nuclear reactions. To elaborate further, the Sun's core is primarily composed of hydrogen atoms, which are constantly undergoing fusion reactions. In these reactions, the hydrogen atoms are converted into helium, releasing vast amounts of energy in the process. This energy is what powers the Sun's heat and light, which is essential for life on Earth. The fusion process in the Sun is sustained by the intense gravitational forces that exist within its core. These forces are so strong that they cause the hydrogen atoms to collide with each other at very high speeds, overcoming the natural repulsion between their positively charged nuclei. As a result, the hydrogen atoms fuse together to form helium, releasing energy in the form of gamma rays and other particles. Although there is no oxygen in space, this does not affect the Sun's fusion process since the hydrogen atoms do not require oxygen to undergo fusion. Instead, the hydrogen atoms fuse together due to the strong nuclear forces that exist between the atomic nuclei, which are much stronger than the electromagnetic forces that cause oxygen to react with other elements. Overall, the Sun's ability to produce energy through nuclear fusion is not dependent on the presence of oxygen, but rather on the intense gravitational forces that exist within its core. It's also worth noting that the Sun is not the only star that produces energy through nuclear fusion. In fact, most of the stars in the universe are powered by the same process of hydrogen fusion that occurs in the Sun. The only difference between stars is their size and mass, which affects the rate of fusion reactions occurring in their cores and the amount of energy they produce. Additionally, while there is no oxygen in the vacuum of space, there are other elements and particles present that can interact with the Sun's radiation. For example, the solar wind, which is a stream of charged particles that emanates from the Sun, can interact with the Earth's magnetic field to produce phenomena like the aurora borealis. In summary, the Sun is able to produce energy through nuclear fusion reactions in its core, which are sustained by the intense gravitational forces that exist within the star. The absence of oxygen in space does not affect the Sun's fusion process, as the fusion of hydrogen atoms is driven by strong nuclear forces, not chemical reactions.